So if you've been paying attention in class, you know that the last 15 minutes or so got a little sloppy, and I'm making this video to straighten some things out. So we were working on this problem. At noon, ship A was 15 nautical miles due north of ship B. Ship A was sailing south at 15 knots and continued to do so all day. Ship B was sailing east at 6 knots and continued to do so all day. Spit it out, man. The visibility was 5 nautical miles. We want to know if the ships were ever in sight of each other. Okay, so the way we started this out is we said here's ship A, and it's moving this way, and ship B is moving this way. And we drew in the hypotenuse, and that was what we called their line of sight, and we want to know if that gets within 5 miles, 5 nautical miles. So we labeled some of these things. We said this distance here is A, and this is B, which is true, and this is C. What we failed to do, and by we I mean me, since I guess I'm in charge, what we failed to do is we failed to get rid of the variables correctly. And so while it is true that C is equal to the square root of a squared plus b squared, right? Let me fix this pen a little. So C does equal the square root of a squared plus b squared. What happened was we didn't get rid of these variables correctly. And just to be clear, I figured this out as usual about 5 minutes after you walked out of the door. I did not peek at my notes because I'm stubborn and I refuse to do it. I always believe that I can figure these things out. It's just lately I've been a little slower than I usually am. Okay, so here's the deal. To figure out the distance A, we need to think about where it started and how it changes over its trip. In other words, how it changes over time. So check this out. What I know about A is it starts out at 15 and then it gets smaller. And it gets smaller at a rate of 15 knots. So every hour we lose 15. So the way we write that is 15 minus 15t. We also know about B. B is getting bigger, and it's just 6 times however many hours you have. So this would be 6t. So rather than try and convert this into terms of A or B, like I rushed through doing in class, what we really need to do is write this in terms of t. And so instead of a squared plus b squared, we're going to write c equals the square root of 15 minus 15t squared, that's our a squared, plus 6t squared, which is our b squared. This is the function that we're going to optimize. And what we want to find out is, do we make it within the visibility? In other words, is our minimum less than 5? Okay, let's transfer this to another screen and let's do some math. Okay, so we're going to take this derivative. But first, let's clean this up. Where's my pen? There it is. So this is going to be c equals, I'm going to expand this polynomial. It's 225 minus, 450t plus 225t squared plus 36t squared. And these are like terms. So we have the function c equals the square root of 225 minus 450t plus 261t squared. We need to take the derivative c prime so we can find our critical points. The derivative is, 1 over 2 square root of 225 minus 450t plus 261t squared times the derivative of that by the chain rule. That would be negative 450 plus 522t. Okay, so we've got our derivative, And to check critical points, a fraction will only be 0 when the numerator equals 0, and it will only be undefined when the denominator equals 0. So we're going to check each of those out. Okay, so we're going to set the numerator equal to 0, and I think without too much trouble you'll see that t equals 450 over 522, which I think is around 0.86-ish. And if you plug this into c, guess what you get? You get 5.6. That's the minimum distance. Or we think that's the minimum distance. What we haven't checked yet is the critical points on the denominator. But this is where that 5.6 came from in our answer. What that tells us is that, in fact, no, the ships do not see each other, right? Okay, just to clarify, let's make sure that this thing has no zeros. Right, this was the denominator. Okay, so we need to make sure that expression underneath, I guess I don't need the radical. We need to make sure that this expression doesn't equal 0. And there's a couple different ways to do that. I'm just going to graph it and show you. Actually, I don't even need to graph it. All we have to do is check the discriminant and show that it's negative, meaning there's no real solutions to this thing, right? It's not going to cross x-axis, and so when you do that, you get something like negative 264,195. My point is, there's no critical point associated with the denominator, right? There's no undefined critical point. So this is our minimum. If you want to take the second derivative and make sure that this is a min and not a max, that's fine. But we can also graph this thing and show this is a minimum. So there is a critical point at time t equals 0.86 where ship A is almost to the spot where ship B used to be, and ship B is almost at 6, right? So it's going to be something like this. That is where the line of sight is its shortest, which is at 5.6 miles. But certainly it's not within our visibility, so there you have it. This is the discussion that we should have had in class. As you know, we didn't, but better late than never, I guess. So continue to keep up your studies for the exams. Good luck, and if you need me, you know where I am. See ya.